Hello class, we're just going to quickly go through a review about how some of these functions work, starting with constant and going down to cubic. Okay, so a constant function means a horizontal line, okay? It never changes. It's constant all the time. The degree of that with the highest exponent, well, there is no exponent with it, so that highest exponent is 0. Okay, so if we had a value there, if we had a variable, the exponent on that variable would have to be 0 to make it 1, to make it stay the same. For example, now we're going to talk a little bit about this leading coefficient. Leading coefficient means the first number in your function when your function is written in standard form in the proper order with the highest exponent term first. And so that first term, for example, here is just the c. Here it's a, leading coefficient would be the a of the x. Leading coefficient here in a quadratic would be the a, the coefficient in front of x squared. Leading coefficient of the cubic would be the coefficient in front of x cubed. Okay, so back up here to a constant function. We know what these look like. For example, leading coefficient is positive, so if that number is 1, y equals 1. We all know what y equals 1 looks like. It's this graph. Okay, where it crosses the axis there at 1. Now, if that leading coefficient is negative instead, we've studied this already with quadratics, with exponentials, with trig functions. If a is negative, there's a reflection in the x-axis. Okay, so then that leading coefficient means there's a reflection in the x-axis. So this graph now exists down here and goes through -1. Okay. Linear functions, you're probably most used to seeing this as y equals mx plus b, but I can put an a there instead to represent that vertical stretch or compression. The most simple linear function is y equals x, and we all know that guy. We've used it for inverses as well. Y equals x is that diagonal line, okay? And its leading coefficient is positive, okay? So the value of a, 1, is positive. Now, if that leading coefficient is negative, like in y equals -x, then that's going to be a decreasing function like this, reflection of this graph in the x-axis, and it's a decreasing function. On to the quadratic. Oh, forgot to say the power here. The degree or the power, the highest power is 1 in this case because there's an exponent of 1 right here. Okay, power or degree of this quadratic is 2. Highest exponent is 2. Okay, the most simple quadratic is y equals x squared. We know that that looks like this. Okay, and you'll notice that that exponent 2 is an even number. Okay, and even numbered polynomial functions end up with the far ends going in the same direction, both up or both down. Okay, so here's if the leading coefficient is positive, they will both go up. If the leading coefficient is negative, like we know this would be our most simple -1, it would be a reflection of this graph in the x-axis, and so it will go down like this. Okay, so even power, and both graphs go down the same way. That's not drawn very well. This is a parabola that comes down like this. Okay, excellent. On to the cubic. So a cubic would be a brand new one we haven't seen before. If the cubed, the 3 is the biggest exponent here. Okay, so the degree is 3, or the highest power is 3. A cubic, if the leading coefficient is positive, a cubic function will look like this. Okay, so it starts down. On the left-hand side, it goes down. On the right-hand side, it goes up. All right. The opposite is true if that leading coefficient is negative, or if we think about this being reflected in the x-axis, then that graph is going to be like this. Okay, but the idea here is an odd power, so it makes sense that the beginning and the end of the graph are going in different directions. One goes down, the other goes up if the leading coefficient is positive, and if the leading coefficient is negative, it's the opposite way around. The left side goes up, the right side goes down. Okay, stay tuned for the next video. We'll go on to quartic and quintic functions.